Okay, so let's move on to the last conic, known as the hyperbola. Here's the definition of it. A hyperbola is a set of all points in a plane for which the absolute value of the differences of the distance from two fixed points, known as the foci, is constant. Now, if you notice, this definition sounds extremely similar to us. It sounds like that of an ellipse, except the ellipse was the sum of the distance. And in the hyperbola, it's the difference of the distances. And notice they say the absolute value because the difference of the distances needs to be a positive number. Because whenever you talk about distance, distance is a positive number. Are you with me? Okay, so here's what I'd like you to consider. Actually, here's what I'd like you to think about. I'd like to actually have you think about a hyperbola as a pair of parabolas. And these pair of parabolas are either going left and right or they're going up and down. Are you with me? Now, notice what I wrote here. Transverse axis. If you remember when we dealt with parabolas, right? We had an axis of symmetry, didn't we? And this axis of symmetry cut right through the middle of the parabola. And if I folded the parabola in half, the left and the right side were exactly the same, weren't they? They matched up. I'd like you to think of the transverse axis as the axis of symmetry. Now, instead of one parabola, though, I have two. In this particular case, they're telling me that the transverse axis is horizontal. Let me back up. Here, my axis of symmetry is vertical, isn't it? And since this axis of symmetry is vertical, this parabola goes up, or it could go down. Agreed? If the transverse axis, and I'd like you to think of it like the axis of symmetry, if the transverse axis is a horizontal, that means your parabola is going left or right. And since it's a hyperbola, it's a pair of parabolas, which means they are going left and right. Are you with me? Okay, so now here is the formula or the equation, the format, standard form for a hyperbola that is going left and right, that has a transverse axis that is horizontal. Now look at the formula. What do you notice about it? Yeah, if you said that looks like the formula for an ellipse, you're absolutely correct, because the definition is extremely similar, except for the ellipse it's the sum, but on the hyperbola it's the difference. Are you with me? And you're going to notice things are pretty much the same in terms of the information I pick out. First thing I want to do is identify the radii. So the radius in the x direction and the radius in the y direction. I still want to identify those. So what would be the radius in the x direction? Good. It would be a, because the a is under the x. And what would be the radius in the y direction? Excellent. That would be b, because it's under the y. Your center would be, excellent, h comma k. Now, since this is horizontal, and that means it's going left and right, that means which of these coordinates is actually changing? Good, the h is changing. And to get to the one to the left, you're going to subtract. And you're going to subtract by what? Yeah, the a, because the a is the radius in the x direction. And to get to the one to the right, you're going to add, because, and you're going to add by a, because that's the radius in the x direction. Good? Now the foci, still looking similar to the ellipse. To get to the one to the left, it's minus c. To get to the one to the right, it's plus c. And you're like, okay, is c exactly the same equation? Not quite. In this case, c is equal to the square root of. Now, remember on the ellipse, in the standard form, there's a plus sign here, correct? And when you found the c for the ellipse, there was a minus sign under the square root, wasn't there? The hyperbola is opposite. The hyperbola has a minus sign in the standard form, and in the C, there's a plus sign. So I don't really care which one is larger. I don't, because I'm adding, so it doesn't matter. Are you with me? Okay, good. Now, there's one difference right here when it comes to the asymptotes. You're like, a hyperbola has asymptotes? It certainly does. And these asymptotes are lines. Now, here's what I'd like you to remember. We had a formula that we did when we were working with lines in previous math classes prior to this one. And we kind of went over it a little bit, at the beginning of the semester. We have this point slope formula. And if you remember that, that's y minus y1 equals m, which is the slope, correct? Times the difference of x minus x1. That's my point slope formula, isn't it? Okay, to find my asymptotes, it is this formula, except the slope is going to be looking a little different. So don't write, just watch a second. So y minus y1 equals, and then we have the x minus x1 on the other side. Now, the slope. When you find slope, slope is the change of the y's over the change in the x's, correct? Well, and keep it this simple. What's the radius in the y direction? B. What's the radius in the x direction? A. You're like, it's that simple? It's that simple. That's how the slope is determined when it comes to the hyperbola. By the way, there's not one asymptote, there's two. Do you notice I have the plural s here? The other one is, this is a positive slope. The other one is the negative slope. Good? Okay, so hang in there. I'm going to come back with the other formula where the transverse axis is actually vertical. Okay, so now let's look at the formula for the transverse axis being vertical. So if it's vertical, I have a pair of parabolas going up and down. Are you with me? Remember, I want you to think of transverse axis like the axis of symmetry, which means if it's a vertical axis of symmetry, it's cutting through a parabola going up and one going down. That creates the hyperbola, a pair of parabolas. Got it? Okay, now here's the deal. Notice the formula for this one? There's still a minus sign in between, correct? But notice which variable is now first. Yeah, the y. The y is first. Actually, if you want to think about it even better, the y is positive. When my transverse axis is vertical, the y variable is the positive one. There's technically a positive sign in front of here. On just a little bit ago when the transverse axis was horizontal, the x was written first, but more specifically, the x had a positive sign in front of it. Got it? That's important because they could flip these on you and put the negative first just to see if you're paying attention. Okay, so because of that minus sign, I'm dealing with a hyperbola. And yes, I am going to first figure out the radius in the x and the y direction. So what's the radius in the x? Good, A, because it's under the x, and B for the y, because it's under the y. My center, excellent, H comma K. Vertices, which coordinate's moving, the H or the K? Good, the K, because this is vertical, and that's the y coordinate. Now, to get to the one below it, you're going to subtract, good, subtract by how much? Yeah, B. And to get to the one above, good, you're going to add by B, the radius in the y direction. To find your foci, to get below, good, minus C. And to get above, good, plus C. Now remember, C is equal to the square root of, good, that's a plus sign, A squared plus B squared. By the way, these foci are still inside the parabolas. So in this case, if I have, since it's vertical, that means I have parabola going up and a parabola going down. Your foci, here are your vertices. Your foci are still here. That's the foci. Your foci are still here, inside. Just letting you know that hasn't changed. Got it? Okay, asymptotes. Yeah, they're still lines. So y minus y1 equals, now just wait before you write, x minus x1. Remember, slope is the change in the y's over the change in the x's. Well, yeah, y is b. So b over the radius in the x, which is a. This is the positive slope, and the other asymptote is the negative slope. Good? Okay, hang in there. Got a couple examples for. Okay, so let's look at these directions. They ask us to find the pertinent information for the conic. So, we have 4 choices now, don't we? Circle, parabola, ellipse, and now hyperbola. Agreed? Which one do you think this is? Yeah, x and y are both squared, which means it could be a circle, an ellipse, or a hyperbola, right? So, how can you tell which one this is? Good. Some of you are like, wait, there's a minus sign. Yeah, there's a minus sign. There's only one conic that has x and y squared with a minus sign. Which one is it? Good. The hyperbola. This is a hyperbola. Excellent. Do you know its transverse axis? Is the transverse axis horizontal or is it vertical? Some of you are like, how do you tell again? Which one of those variables squared is positive? The y. And y's go which direction? Up and down, which means it's vertical. Is it in standard form? Nope. But here's the cool thing. I don't need this in standard form to know that the transverse axis is vertical. Got it? Okay, so this looks like something we did when we talked about the ellipse. It's not in standard form. Standard form for a hyperbola, as well as an ellipse, must be equal to 1, and this clearly is not equal to 1. So what are you going to have to do? Excellent. You're going to have to divide the entire equation by 324 so it equals 1. Yes? Okay, so I'm going to simplify as I go. Hopefully you're agreeing with that 36 on the bottom. Yeah? Okay. What's the radius in my x direction? 18. My x is here. What's the radius in the y direction? 6. Good. Center? Yep, 0, 0. You're like, hey, this sounds like the ellipse. Yeah, it sure does. There's one difference which makes it quite different in its shape and the graph. But for the most part, finding this information is the same like we did for the ellipse. Okay, vertices. Which coordinate is changing? The h or the k? Good, the k, because it's vertical. So, 0, yeah, minus the 6, right? Which would, what's 0 minus 6? Good, negative 6. So I'm just going to write negative 6 here, because you guys know this. And the other one would be this 0 plus 6, which just gives me 6. Excellent. Foci. You're like, hey, you got to find that C. You're right, I do have to find that C. Okay. So C is equal to the square root of, excellent, A squared plus B squared. It's an addition problem. So 36 plus 324, which is the square root of 360. And if they don't ask for a decimal, you can't give them one, so it's 6 square root of 10. Got it? Okay. So remember, the x is, the k, I'm trying to get k out. The k is changing. So it's going to be 0 minus this. And then it's going to be 0 plus this. Good? Okay. 2 other pieces of information. Yeah. Here's the one extra piece of info we need to find, which is a huge difference from the other ones. I need asymptotes. Now, in the previous slide, shall I say, I wrote y minus y1, right? And x minus x1. Well, in actuality, that's y minus k and x minus h. Good? And it's still the change of the y over the change in the x. So in this case, Well, first asymptote is going to be y minus, 0, equals the radius in the y, which is 6, over 18, which is the radius in the x, and then x minus 0, that's the h. So we get y equals 1/3 x. That's one asymptote. But there's a second asymptote. And the second asymptote is still y minus 0, but now it's a negative slope. Good? Okay, so my second asymptote is a negative 1/3 x. Good? Okay. Now, gratefully I left myself some board space because I want to graph this because I need you to see what this hyperbola looks like. I have a center of 0, 0. Agreed? One vertex is at 0, negative 6. The other one's at 0, positive 6. My foci. Well, isn't 6 times the square root of 10 larger than 6? Good. Which means one of my foci are up here. And then negative 6 root 10, the other one is going to be down here somewhere. Okay? Now, let's talk about these asymptotes. So this has a plus 0 for a y-intercept. And I go up 1 and right 3. Or I could go down 1 and left 3, couldn't I? So here is your y equals positive 1/3 x asymptote. The second one has a y-intercept of 0 also, doesn't it? So 0 and down 1, right 3, or up 1 and left 3, correct? And when you connect these dots, here is your y equals negative 1/3 x asymptote. Okay. Now here's the deal with the asymptotes. The asymptotes actually give me an idea of how wide my parabolas are, or the hyperbola, when I look at it as a single object. So this is my vertex right here. The parabola down here, the one going down, is pretty wide. It crosses through that vertex and it's about this wide. And your graph might look better than mine. And up here, same thing. It's pretty wide. It crosses through that vertex. Cool? Okay, hang in there. I got another one of these. Hopefully it's making some sense so far. Okay, so let's look at the second problem. Which conic do you think it is? Yeah, I see an x and a y squared, but what's in between that x and y squared? A minus sign, which means hyperbola. Excellent. Now wait. What's the transverse axis? Which of those squares is positive? Good. X is positive, which means your transverse axis is horizontal. Excellent. Good job. Is it in standard form? Nope. You're like, wait, don't tell me. Do we have to? Yeah, you do. You got to complete the square on this thing. Didn't we do an ellipse problem like this? Told you, these guys are kind of similar to each other. So follow along with me. Hopefully you see what I'm doing. I am going to put the x's together as I move that 36 to the other side because it doesn't have a variable. I need my lead coefficients to be a 1. The x's are okay, but clearly the y's are not okay because in front of y squared is a what? Yeah, there's a 9. As a matter of fact, it's a negative 9, which means I'm going to factor out a negative 9, which leaves me y squared plus 4y. Y plus because you divided a negative out from the negative 9y squared and the negative 36y. Okay. Is it now ready to complete the square? It is. So, for the x's, I take the negative 10, I take half of it, I square it. What do you get? 25. So that means I'm adding 25 here, aren't I? Which means I'm adding 25 here, aren't I? The y's. You take the 4, positive 4, take half of it and square it, which gives you 4. So I added a 4 inside the parentheses. Am I adding a 4 to this side? Good, you are not. Because this 4, this plus 4 that you added in here, is being affected by the minus 9 on the outside. So it's actually a minus 9 times 4 that you added to both sides. With me? This positive 4 that you put in the parentheses is being affected by the minus 9 on the outside. So technically you subtracted 36 there when you distribute. Okay. Remember, the whole point of completing the square is so we can factor. So the x's will factor. The y's will factor. And when you combine this side together, looks like I just get 25. Good? All right. Standard form yet? Nope. Got to divide everything by 25, don't you? Because it must be equal to 1. And I don't know about you, but now I'm having a little bit of a challenge. Why? Because 9 does not go into 25 evenly. That ain't reducing. Oy, you've got to be kidding. All right. I have to simplify this fraction before I can go any further. All right? So, you're like, how are you going to do that? Come over here. Let's watch. I am just going to look at the negative 9 over y plus 2 squared, and I've got to simplify this because this 9 is not allowed to be there. Standard form has just a 1 in front of that parenthesis, no other number. So, see if you agree with this. Isn't this technically 9 times that? So couldn't I rewrite this as negative 9 over 25 times this parenthesis? Do you agree? Okay. Because if I multiply this back together, this parenthesis would be at the top next to the 9, right? Okay. I want to look at it a little differently. And as a matter of fact, I don't really need to look at the negative because I know this is going to be negative anyway. So I'm going to get this 1 sign out of my way because I don't want to focus on too much. I don't need to focus on stuff I don't need. Is this the same? Hopefully you said yes. All I did was reverse the multiplication order. Good? Now, if you remember, we're not used to going backwards on this, but here's the deal. When this fraction turned out to be a multiplication problem, it came from a division problem of fractions. If I multiply by 9 over 25, that means I'm actually dividing by what? Yes, you're dividing by 25 over 9. I'm going backwards. Think about it. If you had this division problem of this divided by 25 over 9, wouldn't you change this to multiplication and flip this guy? Yeah, change to multiplication and flip it. Got it? Except now we're going in the reverse order. We're not used to going this direction, but we're going this direction. Because we need to. Because I can't have that 9 on the top next to the parenthesis. So, this is how the second fraction actually looks. I have x minus 5 squared, the parenthesis squared over 25, minus y plus 2. Sorry, somehow I changed that y to x's. Sorry about that. See, this is why I need you guys doing it with me. These are all y's. My fault. See how used to we get to x's? Okay. Y plus 2 squared over 25 ninths. equals 1. Here is the standard form of the hyperbola that we're going to be working with. Got it? Okay, so stay tuned. I'm going to clear this board space, rewrite our standard form, and then we're going to find all the pertinent information that they want. Okay, so here's the hyperbola we came up with. We know the transverse axis is horizontal. So now let's gather our information. The radius in our x direction is what? Good, 5. The radius in your y direction is? Good, 5 over 3. You know how to take the square root of that. That's easier than you think, I should say. The center, yeah, positive 5, negative 2, right? Positive 5, negative 2, just like the ellipse. You got to set them equal to 0. Vertices. Since my transverse axis is horizontal, which is moving? The h or the k? Good, the h is moving. So 5 minus, good, 5, because that's the radius in the x direction. And then the other one is 5 plus 5, which means my vertices are at 0, negative 2, and 10, negative 2. Good. Kind of already like the ellipse, right? Not a whole lot of change. Foci. Okay, so 5 minus something, right? And then the other one is 5 plus something. You're like, that something is c. You're right, that something is c. All right. C equals the square root of, oh, we're adding fractions, 25 plus 25 over 9. Lovely. Get your common denominator. Good, 9. So 9 times 25. Good, 225 plus 25 all over 9. That's the square root of 250 over 9, which turns out to be 5 square root of 10 over 3. If they want a decimal, fine. I'll get it into the calculator and give them a decimal. If they don't want a decimal, then we've got to leave this funky little fraction. So understand that. Cool? All right, what's next? Asymptotes. There you are. So, one of the asymptotes is y minus k. What's my k? Negative 2. And x minus h, 5. Okay, so remember the slope. It's your y over your x, correct? So that means it's 5/3 divided by 5. Well, what's that going to be? Yeah, I think I heard some of you say it. That's 1/3, isn't it? Right? And over here is x minus 5. Looks like I've got some simplifying to do. 1/3 x minus 5 over 3. You need to minus that 2 from both sides. So when you minus the 2, and I know some of you need to see this, what is negative 5/3 minus 2 over 1? Common denominator, right? Okay, so make sure, whoops, 6 over 3, sorry. So that is negative 11/3. Good? But I have a second asymptote. And the second one is just like this one, except the slope is supposed to be, yeah, a minus sign in front, which means wouldn't I be right at this point? Wouldn't that be the same? Because wouldn't I still be dividing the numbers in this order? Good. So, distribute. And now in this case, you have got a positive 5/3 minus 2. And we already know the 2 is 6 over 3, which would give me negative 1/3. Good? Okay, I found the pertinent information they want. If they want me to graph this, I can graph this. My parabolas would be going left and right. and they would touch the vertices 0, -2, and 10, -2. Cool? And I know some of you are like, can you show that? Okay, hold on. I need board space to show it. So hang in there. I'm going to erase this asymptote work because it's taking up the majority of the board. But if you notice, except for the asymptote, everything else is just like our ellipse, correct? The format is the same except there's a minus sign in front. So however I put the ellipse in standard form is how I put my hyperbola in standard form. You with me? Finding the radius in the x and the y direction is the same as the ellipse. Finding the center and the vertices are the same as the ellipse. The foci is a little different because the foci formula has a plus in between, a squared and b squared, whereas the ellipse has a minus in between. Okay. Got myself some board space. Now, where's my center? 5, -2. Okay, so 5, -2. Here's your center. Your vertices, 0, -2. Whoops, sorry about that. You go away. 0, -2, right here. That's one vertex, and the other one's at 10, -2. This dot's got to go away. It's bugging me. So this one's at 5. There's the other vertex. One of those asymptotes was 1/3 x minus 11/3, right? So minus 11/3 is a little bit over 3. Almost 4, right? 2, 3, 4. It's almost here. And I'm supposed to go up 1 and then over 3 to the right. So, by the way, your asymptotes will always cross through the center. I'll say it again. The asymptotes always cross through the center. So make that note for yourself. The other one was a -1/3 for your y-intercept, and then down 1 and 2, 3, okay, which means, and this is the y equals -1/3 x minus 1/3. And that line, I'm going to dot it up. Gratefully, with a light board, it's easy to make the dotted lines just like a whiteboard, right? Okay. And now, these are pretty narrow, but here's this one, and here is this one. And if you're going, where are the foci? I guarantee you one foci is here and one is here. Cool? Okay. Hang in there. We're going to go backwards, and now we're going to go find equations of hyperbolas.